Martin got a job at a starting pay of $8 an hour. His boss told him if he works hard, he can get a raise each year. The table shows Martin's wage for the first few years. Find Martin's hourly wage after 6 years. Round to the nearest cent. All right, so first thing we're going to do is find out, is this an arithmetic sequence? If it is, it'll be subtraction and addition, and that's the easiest one to solve to determine whether it is or isn't. So 11.52, it'll have the same common difference. Minus 9.6, that's $1.92. 9.6 minus 8, that's $1.60. It's not arithmetic, which means it might be geometric, and we need to determine that. Remember, to solve if something is geometric, we're going to divide 1152 by 9.6 and 9.6 by 8 to see what we get. So 1152 divided by 9.6, that's 1.2. 9.6 divided by 8, that's also 1.2. Okay, so that means that Martin gets a 20% raise each year. And I say 20% because if you notice this right here, if I multiply something by 1, it stays the same. And the 0.2 is 20%. So he keeps what he made the first year, and he's adding 20% every year after that. So let's look. Remember, geometric sequence, a sub n equals a sub 1 times the ratio to the n minus 1. So we already know our ratio, and we already have a sub 1. So a sub n equals 8 times 1.2 to the n minus 1. And they want us to find out what his wage will be at year 6. So a sub 6 equals 8 times 1.2, 6 minus 1. Or a sub 6 equals 8 times 1.2 times to the 5th. All right, now let's find out. So, turn my calculator on. 8 times 1.2 to the 5th power is 19.90656. So, 19.90656. The question asks us to round to the nearest cent, so we know cents goes out to the hundredths. So I'm going to look at my thousandths. 6 rounds up, so it's going to turn that 0 into a 1. So $19.91.